this video, we're going to talk about solving exponential equations. So I've got a basic example, 2 to the x is equal to 2 to the 5th. Notice the bases are the same, so it makes sense that I could set the exponential powers equal to each other. So x equals 5 is the only solution since it is a function. Remember, every single value in the domain maps to exactly one value in the range. Therefore, if I can get the bases to be the same, I can set the exponential powers equal to each other. All right, so let's solve the following equations then. We've got 9 to the x is equal to 27. Can I rewrite 9 and 27 as numbers that have the same base? And the answer to that is yes. I can rewrite 9 as 3 squared, and I can write 27 as 3 cubed. Now, the bases are the same. I can set the exponential powers equal to each other. Remember, an exponent power to another power, you multiply, so that's 2x equal to 3, and x equal to 3/2. All right, so let's take a look at another example then. I've got 4 taken to the x minus 3 is equal to 1 over 64. Now, again, can I get these to be the same base? Well, let's take a look at 1 over 64. Well, 1 I'm going to leave the same, and 64 I can rewrite as 4 cubed. Now, I don't necessarily want that in the denominator, so how can I get that up to the numerator? Well, it's a negative exponent. So 1 over 64 is equal to 4 to the negative 3rd power. So that helps then, because now on both sides, my base is 4. So again, now the bases match up. I can set the exponential powers equal to each other. Very simple equation, just add 3 and you get 0. I can easily plug in 0 into the original equation. 0 minus 3 is negative 3, and we already know 4 to the negative 3rd power does equal 1 over 64. So this is a solution. Okay, so now let's take a look at 2 others then. So again, you have to ask yourself, can I get these to be the same exact base? And again, 5 and 25, that's fairly simple to see, yes. Because we know 25 is 5 squared. Now the bases are the same. I can set the exponential powers equal to each other. So it's 3x minus 1. Don't forget now, I'm going to distribute the 2 to both the x and the 3. That's 2x minus 6. Again, very simple equation to solve from here. And I get x equal to negative 5. So let's go back and plug this in just to show that x equal to negative 5 is a solution for this. So I'll check here. So plugging into the left-hand side, 3 times negative 5 is negative 15, minus 1 is negative 16. So I have 5 to the negative 16 on the left. To the right, negative 5 minus 3 is negative 8, so it's 25 to the negative 8. So again, I can rewrite as the same exponent. Remember, when you take an exponent power to another power, you multiply. I really don't care what 5 to the negative 16th is, but I know 5 to the negative 16th power equals 5 to the negative 16th power, meaning x equal to 5 is a solution here. One other example then. Again, if I can get the bases to be the same, I can set the exponential powers equal to each other. So 4 and 8, I can rewrite each of those as a base 2. Now that the bases are the same, I can set the exponential powers equal. So again, I'm going to distribute the 2. And 3 times 2x is 6x. Now, that is a quadratic equation. I've set quadratic equations equal to 0, so I'm going to bring over the 6x. I'm going to divide out a 2. Now, I'm going to check to see if that's factorable. In this case, it is. I can break it down as x minus 2 and x minus 1. Okay? So I know x is equal to 2 and x is equal to 1. So let's check x equal to 2. So go back to the original equation. 2 squared is 4 plus 2 is 6, so that's 4 to the 6th. On the right-hand side, 2 times 2 is 4, that's a to the 4th. Rewrite. And you can see that's 2 to the 12th is equal to 2 to the 12th. So x equal to 2 is a solution. All right, let's check x equal to 1. So from the left-hand side of the original, that's 1 squared is 1 plus 2, that's 3, so that's 4 cubed. 2 times 1 is 2. Rewrite. And we can tell on both sides that's 2 to the 6th is equal to 2 to the 6th. So x equal to 2 and x equal to 1 are both solutions to this equation.